We have uh, system and 6aux table space. Okay, so okay, so I talked about the table spaces with you. What are table spaces? You understand what table space is? A table space is a kind of a logical division of data files. Okay, so like assume I have a lot of data files in a database. These are the files are there to store the data. So now it would be very confusing for me, like to have this many data files. So I can divide this data file maybe 10 with some logical purpose. Okay, so when you're creating some table, I told you when you're creating a table, you assign it to some table space. Okay, not to any data file. So you will say create table space this. So table says data by defaulted. Just assume there's a table space, maybe users or table space of finance. Okay, so all the financial data are put into that. So you say create table. Anything you're creating like create table, payroll, your fields, table space, finance. So the payroll table will go into that the payroll will go into that finance table space, right? So what will happen that like the table is it is getting bigger and bigger. So it will put all its data into that data file which belong to table space. Assume that data files are full, so it doesn't mean that it will move to another table space. It will give the error, right? The data files are full, or data files there is no space, so either add the data file new or resize the data file. So it's kind of you're tying up all the tables corresponding to table spaces. So there are two by default table spaces that are automatically created. There are actually 4 or 5 which are automatically created, but these are the two main important ones which are created for the system purpose. Okay, so system and 6aux. Okay, system table space and 6aux table. System table space, these are the two mandatory which are created in the beginning. So system contains the core functionality, or you can say the data dictionary. Okay, that is containing the data dictionary of the of your database, which you discussed earlier, the metadata. Okay, so metadata, all the information are contained in the system table space. So this is the first table which is created. So data file is also like the has a file ID 1. So this is the first file which is connected to the control file. Fine. So, and it's the first file which is used when we are recovering the database. This is the first file that get recovered also. The first file that get recovered when we are recovering the database, when there's any issue and there's a recovery happening in the database. Fine. So if there is problem in this files or this table space or something, database will not start at all. Okay, whatever you do, it will not start at all. It will crash and it will not start at all. Either other table spaces which you can make it offline or something, you can do it, but in this table space you cannot do anything. If it is crashed, it is crashed. Have to recover it completely before the database starts. Okay, so auxiliary, then there is one more table space, that is 6aux. That is also a system table space. This table space contains the secondary information. Primary information, the system, because that is mandatory information about the tables, indexes, structures, number of rows, number of indexes, and the addresses of the data. So all such kind of mandatory, the information about the database, control files, when the database was created, all the transactions that are running, all the sessions that are connected, all the parameter file, everything whichever is there in the database, like even parameters, copy of parameter files also contained over here, copy of control file is also there. So every kind of information is there in the system. Okay, now 6aux is also a tablespace which contains the system information, but a secondary kind of information. Secondary means which is not that required to run the database. It is not required to run the database. So what kind of information it contains? It contains the information such as the performance information. Okay, the performance metrics of the database. Okay, you can see over here, like it says 6aux tablespace may be taken offline to perform tablespace recovery, whereas this is not possible for the system tables. So system tables can never be offline. Okay, so 6aux contains secondary information of performance metrics, like we have AWR reports, and we have Okay, I don't want to go into that details, but okay, basic details is Oracle database takes a snapshot of your database every hour. Okay, starting from I think 10G or 11G, right? So it'll take snapshot of the database every hour. Fine. That how database is performing, what all wait events are coming, what all queries are running, and how each table, each index, how it is performing. So it contains a snapshot kind of thing of the database. Okay, this snapshot is stored in the 6 logs. Okay, so in addition to this snapshot, there can be some other performance information, which is useful when we are monitoring the performance, when we are trying to improve the performance of the database. Okay. Uh, Then next concept comes is pluggable database and multi-tenant container database. Okay, so this concept came in with Oracle 12c. C stands for cloud. So this concept came with the cloud. So there was nothing like multi-tenant database or pluggable database in earlier versions from 11G. Okay, there was nothing like this. In 12G it came. So what does it means? It means is multi-tenant. What does a tenant? Tenant, you know the meaning of tenant, what tenant meaning is. Like, so multi-tenant container database. So it means is now a database, a multi-tenant the database is container database will contain the multiple, sorry, so this database will contain the multiple pluggable databases. Okay, this is kind of a container database which is container containing multiple pluggable databases. Okay, so all these databases, like maybe a company is running, a small startup company is running, I want to create a separate table space for HR, separate for finance, separate for what else, my sales, my targets. So they're separate databases, right? So these all separate small databases are contained in a single container database, right? So now what is the benefit? What is the benefit of using this architecture? One thing is you use one database, one instance, you mount it and you use it. Okay, or maybe you can use multiple instances and one database. That is also fine. But what is the concept of using multi-tenant? The concept of using multi-tenant is that the databases which don't have that much of activity, which don't take that much of resources, right? Okay, which don't take that much of resources. So what will happen? Uh, you know that each database has so many background processes, server processes, background processes, SGA, PGA, which has some minimum size allocated, but nothing is happening in the database much. So most of these processes remain idle, and right. So it's like, but that processes need to be there. That is mandatory process. But the activity is not more. So resource consumption is low. For such type of database, we can club all these databases into a single database. First thing is all these background processes, database writer, log writers, archive files, everything can be utilized in a better way, right? So it's better consumption of resources. So better resource utilization, you can say. First thing is that. Second thing is better management, like easy to manage. Easy to manage means just want to I have to take the backup of the database every Sunday. Okay, maybe once in a week. Okay, so if there are 10 databases, I need to take the backup of 10 different databases. I need to fire the command on 10 different databases. But here, I just say backup database. That's it. All the databases are backed up. All right. So easy to manage. Patching. If some patches need to be applied, you need not to apply on 10 different databases. You apply only one database. That's it. Okay. So this easy to manage. But if I talk about production scenarios, it is different, right? The production very critical databases, you might not would like to go with a multi-tenant architecture. Because it is reverse things over there. You don't want to mix the production critical databases backups with other database backups, right? Assume the database is very huge, 10 TB, 10 TB or 20 TB. You don't want to mix that 20 TB backups with other backups, and that backups are also 2 TBs or 5 TBs, because your priority for that database is more, right? You don't want to give outage to the database any point of time. So such cases, if there are a lot of dev test databases, you can club all of these things into one multi-tenant architecture, and if there is one production, you keep it separate. Okay, you don't use this because there's a parameter to enable this multi-tenant container database. Second problem with this architecture is like the problem is the benefit over here was told you that if like a patches need to be applied, okay, so it can be applied in one shot. Okay, so but but the problem is like if you're applying a patch and that database, maybe there are 10 databases and 5 needing that patch and 5 not needing that patch, right? But you are applying on all 10, so it is causing outage on all 10, right? So it is causing outage on all 10. So, but if it is a dev or test database, that is fine, right? An outage of 30 minutes or 1 hour is fine. But assume it's a production database. If you put a multi-tenant architecture and there are 2, 3 productions, one production is not needing the patch, two production are needing the patch. So unnecessary you are putting that production database into outage for 30 minutes or 60 minutes, right? That is right. That is not needed. Well, outage thing is the outage is something which is as a DB you need to decide on different, whenever you're doing anything you need to decide on the outage, exporting, importing, backups, how much outage it will take, how much downtime it is required. Just assume your banks, railways, airlines, are they down anytime? No, they're not down anytime, they're 24/7 up, right? So business runs because they're 24/7 up. So how come if they're down then, right? Then a lot of problems will occur the same way. But if a bank has multiple dev databases which are just a copy of the production they have kept inside, maybe for their employees, employees which is containing their employees information or their HR information or the other activities, so it is fine, right? You can give outage of that databases for 1 day or maybe 5, 6 hours. That is fine because their payrolls or HR can if they're 5, 6 hours down, then it's fine with them, right? But they cannot put the down the databases which are actually the customer databases, which has the account balances. If the database is down, that means none of the ATMs will work, right? So in the same way, you're booking the tickets on railways or booking the ticket on airlines, so they can't afford to make it down. Okay, so they lose the business if one just if one one airways is down, so booking is not able to done during that time, right? Fine. So okay, let's go to the so has redundant they all share. So they share all these things: background processes, shared memory, Oracle metadata, to log files, control file, undo table space, temporary table space. Right, so they share all this information. Their SGA, PGA is same, right? So their kind of resource utilization is better, but it is not good, right? For production, it's not good, but for dev and test, this is a very good approach. Because unnecessary, if you say dev or test, they're unnecessary taking up that much memory, that much PGA, SGA. That is something minimum PGA, SGA required. All the background process which might be used or might not be used with that activity level, but they will sit on the database, sit on the server, taking up some space, right? So now comes the ASM. Okay, so let us go through the basics of ASM. This is the way data is stored these days. Okay, so you know that in operating system level there is a formatting that occurs. You might have done sometimes in your past, in your lifetime, you formatted your disk. Okay, so what does it formatting means? You format your disk. So if you don't format, you cannot use a disk. You use a raw disk. So what does the format disk? Format actually does it it creates blocks in your disk. What it does? It creates blocks in your disk so that each block has a block ID. Each block has some address so that the operating system the operating system can locate to that block. Okay, so the person who is sitting, who's monitoring the operating system, who is or doing this, right, their softwares, right, so operating system can go and check, get the block. The raw disk cannot be used, right? So now once formatting is done, the operating system blocks are made, right? So now on the top of this operating system blocks, we'll have Oracle blocks. I told you in the last session, right? So that there Oracle blocks on the top of this operating system blocks. So just assume there are 2, 3 operating system blocks, and now 2, 3 operating system makes one Oracle block. Okay, the same way Oracle blocks are formed. Okay, so but Oracle blocks need to be a multiple of the OS block size. Like if the block size of OS is 2 KB, that is by default size, the Oracle block need to be multiple of that. Either 1:1, like one Oracle block, because they need to match the address. They need to match the address. Otherwise, it will not become possible. So either we can have 2 KB size, 4 KB size, 8 KB size, or 12 KB size. If by mistake you given the wrong size of the block size like 11 KB, automatically it would go to 12 KB or maybe 8 KB. So Oracle automatically adjust. Okay. So now what is happening? Happening is like now operating system talks with the database to give you the data. Okay. So it's a lot of communication happening in the operating system and database. But that is a burden on this kind of scenarios. So what is happening with ASM is ASM formats the disk. Okay. Now with the help of ASM, you are not dependent on the operating system to format your disk. Okay, so ASM will format the disk. You need the raw disk. So ASM is a technology by Oracle database. Okay, it's a technology by Oracle database. It's a cluster file system. So what do you mean by cluster file system? Cluster file system means that that file system, that disk is shared among different machines. So what is the by default file system? By default, like in Windows, you use NTFS. In Unix, you use ext3, ext1. Okay, Windows we have earlier we have FAT32. Okay, file allocation table, and there's a table was formed, and the table has the block IDs. Okay, so but the difference between the non-cluster and cluster is now this disk is used by only one machine. Okay, you cannot connect another machine with your storage system, just like you have a laptop, right, and you have a hard disk on a laptop. So another machine cannot access your disk, right, cannot access your disk because your disk is connected to your machine only. It's okay, it's one to one. Okay, so another machine cannot access your disk. But if it is a clustered file system, any number of machine can access the disk. Okay, because it become a shared disk. It's become a shared disk. That is the concept of cluster file system. So ASM is a cluster file system. Okay, so ASM is given a product given by Oracle. So instead of ASM, you can use another product also, like Veritas was used earlier when ASM was not there. So Oracle databases use Veritas file system if they want to build a cluster system. But you can use ASM now because Oracle has given ASM. I don't know that Veritas is still used some ways, some areas in some databases. Some I've not used it in my past. So similarly, we have ASM, that is the ASM cluster file system. We call it as ACFX also, or ASM, Automatic Storage Management. Okay. Uh, okay. So now what does it mean properties? I told you it's a kind of a formatting you do. So it adjusts the blocks according what is required in the Oracle size. So it is now it should not be a multiple of the OS blocks because OS blocks are not there. You do install ASM on a raw disk. Okay, so there are three main properties of ASM: stripping, redundancy, and rebalance. Okay, so stripping, redundancy, and rebalance, the main three properties. This is very important. So stripping means a data file. Just assume a data file of size of 10 GB or 20 GB. Now, generally what happens, a file resides on only one disk. Just assume any Word document or any file, it resides on one disk. But with ASM, it is not there. Assume the file of 20 GB, it can reside across multiple disks to give you better performance. Okay, it do lot of things internally, you know or you don't know. So maybe just you should have an idea what it is doing, okay, in the background. So it does a stripping means that you can stripping means that you can the file, any particular files, just strip itself and get stored across different disk, right? Across different disk. Now comes redundancy. Redundancy means if you set your redundancy level like one level and two level. Okay, I set two level. There's a normal redundancy, there's external redundancy, and the high redundancy. If you set normal redundancy 2, that means the data you're storing, any table, any index, anything, anything, it is stored in two different places. Okay, to have better security or availability, because disk can go corrupt. Even the disk disk quality is going bad these days, right? Because to save the cost, the disk quality is not that good also. So what is happening is it stores the data into two different places within that particular within that particular disk group we have, which have contained multiple disks. So it's stored in two different areas. It is writing to two different areas. It is reading from maybe one area, but will write simultaneously to two different areas whenever it's update. So that data file or that particular block is written to two different places, and it is internally doing it. So you need not to manage, you need not to worry. It is internally. You just need to set. I want two redundancy level or three redundancy level. Two means two copies, three that is high redundancy means three copies. Three copies are actually not required. It unnecessary impacting the performance. You have three copies, but if it's very, very critical database, might be three is required. Okay. If you don't want to, if there is no scope of outage, no 0.0001% of outage, actually storage doesn't fails. Generally it doesn't fails. It is like 0.01 or 0.001% of chance that storage will fail. But if it fails, then what will happen? You have to recover the database, and recover might take 5-6 hours of outage, right? Right. So does a railway system, airway system, maybe a government security system, army, or very FBI in US, or maybe Indian Army, or whatever it is, like critical finance system of India. So will they afford 6 hour of outage or 10 hour of outage? No. So they have to store redundancy level into different disks. That's why this system is there, ASM is there. But this is not part of the course, honestly speaking. I would be giving you only the theory part and practically not implementing it. Okay. I will try to. Okay. If we get a raw disk, that is not very tough to do it actually. If you want, I can do it as well. So, but not a very deep, would go into very deep levels. Just I'll try to create a ASM disk to you for you to show how to create a ASM disk. Okay, so this is used first is for the cluster file system so that it can shared redundancy. Redundancy stripping is something for better performance. Internally happening, you don't know. Redundancy means it is storing one block in two places to provide better security. If one block or one area of disk goes bad, got corrupted, at least another one is available. Rebalance. Now, what does the rebalance means? Rebalance is also for the performance. It's also happening internally. You don't know how it is happening, but like look, we know how it is happening, but we don't have any control on it. Okay. Now just assume because it is very intelligent system of storage. Okay. So very intelligent system. So uh, you don't need to intervene much. Like you don't know where the files are placed, which disk are placed. You don't know. Just assume there are 10 disks in your Oracle database in a particular machine. There are 10 disks, almost getting full each disk. Now you add two more disks. What happens in the normal scenario? Normal scenario will happen that this 10 disk will get full and will go to the 11th disk, right? Then the 11th disk got full, it go to 12th disk. Just assume in a laptop you add one more hard drive, okay, of 500 GB. So what has happened? The 500 GB, maybe if you want to save a new file into new disk, that is fine. Otherwise It will remain the new disk remains empty, and the old disk is just assumed is 450 GB full and 500 GB size. So both are 500 GB. But in ASM, what happens that you put a new disk, the automatically internally the files start getting moved into a new disk. Okay, so why it happens is, so there should be some empty space to get a better performance. So assume you have 450 GB space full in one disk, and you add one more disk of 500 GB, so that 450 becomes 250. So 225 GB in one disk and 225 GB in one disk. Maybe not exactly, but just approximate figure I'm giving. Maybe 250 in one and 200 in one, something like this. It will start moving it. Okay, it will start moving it internally. It will start moving it, so you need not to do anything. It will start moving it internally, so that some portion remains empty to give you better performance. Second thing, what is that? Similarly, you have 225 GB used, 225 GB used in two disk, 500 GB. Now you want to remove the disk. Okay, now if you remove the disk, you will give a command drop disk, and remove it, take it out from your laptop. Okay, so what will happen? You drop the disk. You don't mean that the data is lost. Data will move back to the disk one. Okay, automatically it will start moving to disk one, and it will not drop till the time it is moved back. So even if you give a drop command, it will not allow you to drop it till the time it is moved back. So you need not to worry about copying the data back to disk one before dropping disk two. If the space, just assume the space occupied in disk 2 is 200 GB, and the space free in disk 1 is 100 GB. Okay, and the space there is 200, it will not drop it. It will give you error. Okay, that free space is not available for the data to move. Okay, so that will give you error. Otherwise, it will start move, and once all the data is moved to disk 1, it will drop the disk. So it's very intelligent system, very intelligent system, cluster system, and very intelligent system. So all these points are same which I have told you. So SM disk group is the collection of one or more disks. Okay, a storage units. So in ASM you don't have operating system blocks, you don't have blocks, so you have ASM allocation units. Okay, so they have ASM allocation units with size is 1, 2, 4, 8, 16 or 32 MB or 64 MB. So you don't decide upon the size, everything is decided internally. You can decide also, but it's better to give it to Oracle to decide. So there is no OS intervention over here. Operating system, it is not formatted disk. It is a raw disk, and you install ASM on top of that. So you just should not be a formatted disk. Otherwise, ASM will not be installed. So this completes the architecture. So we'll move into the installation, and then we'll move into the administration part of Oracle.